the only available values are at 15 and 20. So you have to decide that it's about 20 or a little bit value less than the value given at that point in table 20. So it's not so accurate. But in this case, you can use this formula given in the Excel. So it's given a chi-squared distribution value from a right-handed tail, because we want to know that we are very far away from the normal case, and because it's chi-squared, it has only positive values, we take the right-hand side of this table. In this case, the probability of right-hand tail at this point is only 0.3 promille. It means that it's definitely less than 5%. And this tells us that there seems to be some quality problems. And like here, we just say it seems, we don't say it for sure, because that mistake can be done here in measuring. It doesn't mean that the manufacturing line is the only problem. So if there is lots of small problems, it may cause this kind of case. But anyway, based on this data, it seems that there may be some kind of problems with the quality. So you have to include this one into your report, and you have to do it with Excel. Just take a screenshot or something and add that one there. What is very important for me is that I see your values so that I can check that they are correct. Do you want to ask something about this part? All right. The second thing here is the confidence interval. I don't use so much time for this one, but because the confidence interval is given in every case when you have laboratory measurements and so on, if you read the manufacturing vectors book or something else, it is very often given. And it's also included in SPSS. So if we check what the SPSS gives, here is the mean for the previous example, the mean value, and the 95% confidence interval is from 475 till 492 grams. It means that 95% of your cases are at this interval. It also means that there is a 5% probability that you make a mistake in your results, what you say of what's happening there. The main information here is that with this sample, 500 grams is not included here. 500 grams was the value which we were testing against. And because all of them are lower than our 500 grams, this also gives us the idea that we are not meeting this 500 grams case as we would like to. And these values are obtained with these formulas. So this is the mean of your sample. This one is the value from a t-distribution table with degree of freedom of this one. In our case, it is 15. We want to have a 95% case. So at the lower level, this one is 2.5%, and upper part here it is 97.2. But because this is symmetrical, it is exactly the same value, but they have only different signs. And here, this is the variation. If you know it, you use that one. If you don't know it, you use your sample case divided by your observation numbers. So this one gives you this, but it also can be used for testing this hypothesis. For this one, it is more important that you are just familiar with with how it's obtained and what these values tells. Please remember, this means that every value at this interval has a probability of 95%. It doesn't matter is it 476 or a 491, the probability of that particular point is 95%. Probability of any point outside this interval is 5%. So it's not that it's less if you go far away or less if you are close to this endpoint. It is exactly the same to all points there. Just ask if you have questions at this point.
I do have questions. So in this table, descriptives, there is mention of variance, and the variance is basically a square of standard deviation. So why is it even needed? Like, we can just square standard deviation.
I'm not sure why it's still there. It's probably because it is so much easier to obtain a standard deviation. Just think about the old times when you didn't have the calculators to take the square root. So I think it is just a tradition because, and I prefer that you give the mean and the standard deviation, because standard deviation has the same unit as your mean, but variance doesn't have it. But still, sometimes the normal distribution, for example, is given with the mean and the variance, and in some of the cases with mean and the standard deviation. And this is something where you have to be very careful, because if you don't check that one and you check the value incorrectly, all what you say about your data may be incorrect. And you have to be careful also when you are using programs like Excel. Check which value they actually want there.
Okay, thank you.
Anything else? Okay. Now we just change a little bit order. We did go through the mean of one distribution first and then the deviation test, but now we go through the deviation test first, and after that we start doing the means test. And the reason is that we need to know how the variation or standard deviations are acting there in your case before we can do the mean test. And the test itself is quite easy. As you see, there is the variance of your first case and the variance of the second case. Here, the order is exactly the same. Numerate the first, denominate the second. So it's just a number of observations for these cases minus one, number of observations for these cases minus one. F distribution has 2 degrees of freedom, and one tiny little problem is that if, for example, with degree of freedom 2 and 3 is not same as with in the order 3.2. So it means that you have to check every time the values separately. They are not the same. And here, what we are actually doing is we are just testing whether we can assume that they are the same or not. There is no need to check whether something is less or greater than the other one. For us, it's more important to know whether they are the same or not. Here, the example is not given because this is in the SPSS. And before we go that one, we go also through the mean test here. And this test for 2 distributions means that, for example, when I have this information of my company, you remember I had different kind of workers there. I had managers, I had these office workers, I had guards, security persons, and if I would like to, for example, compare the salaries of office workers and the security personnel, I can do it with this one. So it just takes these 2 different means and checks whether their salaries seems to be the same or they are not. And to do those tests, we have to know whether our standard deviations are known. So it means that where somebody is giving the values for us, or our sample size is so large that we can assume that we know them. If the previous variation test shows that our standard deviations can assume to be equal, then we should use this test. So we should combine the standard deviation to one value, because we can assume that they are the same, but we haven't got exactly the same number. So this is some kind of a compromise of them. And in the third case, our sample size is quite small. Standard deviations cannot be assumed to be same, and we don't know the actual values. We should use this test. What in your case is good that the SPSS is using always this test, because with large When your sample size is big enough, these values are quite close to each other. The normal distribution and t-distribution are almost the same of the sample size at 30. But in this case, if the standard deviations can assume to be the same, we have to use this case. About this, but assuming whether they are the same or not, please remember to think about the case, because any program, SPSS, Excel, MATLAB, MATCAD, they are just checking the values. They don't think about the case. So you can get that it gives you that they should be assumed to be the same, but you are checking the values of different manufacturers, for example. And in that case, there is no sense that saying that we assume them to be the same. Although the values are same, you go with the idea that they are not the same. So the checking happens so that whether these are exactly the right. It seems that I'm not showing you anything today about the SPSS recent license problem, or whether they are not the same. We can also have whether it is less or greater than the other one. If you want, it doesn't matter. You can always use the same shape. So if we go through this coffee packets case here, we take the test. We got the mean for both of them. We have the number of observations, and we have the standard deviations given here. And when we are doing this mean test, we have to start with the standard deviation test. Here is the test value obtained with the idea that we compare this score to this one, and we get the value. Here I have to say that this Leibniz test for equality is a little bit different, but with these values compared to one I showed, it is a little bit more accurate, but still it's giving same kind of results as in my case. So for example, here, if I check the F-test value with these standard deviations, because the value here is less than 1, I thought it could be v squared divided by v squared, but it is not giving this value. So how we are getting this F value is a little bit different. But anyway, compared that value in the F distribution with a degree of freedom of 7 and 7, it will give you that the significance is about 80%. This is more than 5%. So we have no evidence against the null hypothesis. It means that we have to assume that in this case, these standard deviations are exactly the same. It means that from this table, from this point forward, we are only reading this line. The other line is for nothing. We don't need it. So the mean test value is 2.6 with degree of freedom 14. The significance is about 2%. This is less than 5%, meaning that there seems to be is, evidence that these means of these two coffee packages are not the same. Although this is a two-tailed case, if you multiply this one with 2, you get 4.2, and it's still less than 5. So based on this one, it seems that these are not the same. Okay. I still have some problems here with the SPSS, so
Ivy, can I ask you to clarify just a little bit on the F value? So it's a test quality number, right?
yeah. So it's just checking the standard deviations, yeah, or variances.
So the smaller it is, the better, right? Or
Hey, of course, yes, because when the difference is small, but it doesn't matter what is actually the value here. You just check the value here, whether it is less or more than 5%. You always compare to the 5%.
so what does significance tell us? Like,
If it's
what sense?
like in this case, this is more than 5%, it means that there is no difference in the standard deviations, or like it says here, the variances equals. Although the values are different, but they are not too far away from each other.
Okay,
If it's less, then they are too far away, and then you have to read this line for the mean test.
but why is exactly 5%?
It's just commonly used. Of course, you can do it at 1% level or 1 promille level, but in that cases, for example, in 1 promille level, you are demanding quite much. So it's mainly used when we are checking medical drugs or something that must be basically exactly what is needed. If you use the 10% level, you give her too much space. So mainly used is 5% level and 1% level. Anything else? Let's check whether you can open the SPSS, because for me it's not opening. Because if somebody can open the SPSS, I would like him to share the screen so I can tell him or her what to do, and
You can
still I
share.
can and I can explain what do you get. good.
Should I open like flats data or a new?
Just take away SPSS open and your data in there. So okay, and then go to the analysis and compare means there and take the means. And take, for example, the sites and dependent. Put also the independent list and put the city in there. Okay, just okay. So now we have 4 different cities. The mean size of different flats are given here. So for example, in my case, I see, in this case, I see that in city 2, the flats are a little bit bigger. They are 77 square meters in average, and in city 4, only 73 square meters per apartment. But as you see, a number of flats in city 2 is only 30, and in city 4 it's 48. So now we can check whether these flats, basically we could say that the mean size is the same. So go back to the analyze, the compare means, and take the independent samples test. Not this one. Close this one. Close this one. Close. Analyze. And independent. No, you take the same. You didn't go too down enough. Close this means close. Now analyze, compare, stay there, independent, that one. And now take the sides to this test variable and the city to the grouping variable. The first one. Define groups. The group 1, put the value 2, and group 2 value 4. Now we are checking the city 2 and city 4 to each other, and okay. So you see the same values here, and now we have the mean test here. Here is the variances test. Value is greater than 5%. So we have to read only the first line. Here is the test value for means, and significance here is less than 5%. It's actually about 2%. So now we can say that it seems that in city 2, the flats sold are a little bit bigger than in city 4. If this one would have been, for example, 5.5%, then we would have said that the flats are about the same size, because it would have been more than 5, and we wouldn't have any evidence against the null hypothesis. Go back to the analyze. And here you see there is this period sample t-test. You don't need to open it, just stay there so it shows there. So this is a little bit different kind of case as measuring the means. For example, just think about that you have thermometers in your own study room, and you have, for example, three different manufacturers cases there. So basically, they are in the same spot, but because they are from different manufacturers, the values they are not exactly the same. So this test value is used when we have this kind of case that the values are should be same, but because we are using different kind of uh, equipments, we don't exactly get the same value. So now you can stop screening, and I saw what I mean with this one. And because my iPad is not here, I try to write down with my mouse so it will not look nice. So let's see, we have a thermometer 1, thermometer 2, we have a measurement 1, measurement 2, measurement 3, and measurement 4. And we here, for example, get 19.18. This one gives you a 19.7. This one gives you the second day, for example, it gives you 20.1. This gives you 20.2. And so on. So we have a different values here. In this, for example, if we had salary 1 and salary 2, so this is salary for females, this is salary for males, we have the values. So the mean test we go through today gets these means and checks whether they are the same or not. But here, what we are actually doing in the period sample test, we are checking the difference of these. So we take them all separately. And when we got this, we check whether the mean of them is close enough to 0. Because sometimes the difference can be positive, sometimes negative, but we would like to know whether these two thermometers are giving us the same kind of results. So this is the difference. This is the paired sample test, and this is the normal mean test for two distributions. So for example, if this would be your results from two midterm tests, I should use this test because you are there and your way of thinking and everything affects the results. So this I just wanted to show you so you don't take incorrect test. All right, this is basically everything you need to know and do today. Do you want to ask or do you want to just compare? What you can see at this point? Because for me, it doesn't allow me to. Okay, no. Okay.
What do you mean by see at this point? do you ask about the study material?
Yeah, I had the problems with the Zoom. So we have gone through the hypothesis test for means and for variations. So now you can start doing uh, your data and you ask questions. Am I becoming mad, or can I see Daniela twice here? For me, it seems that you are twice. Anyway, so start doing your own studies, and I still stay here and you can ask questions. What I will do is that I open the breakout room, only one. I go there, and if you have any questions and you want to share your screen and so on, so you can come there. Just every time wait for a minute or two so that